Yes, good evening to everybody. How are you doing today? I hope all of you are fine. Today we want to have a class on star 122, sorry, star 220. There is a computing tool which is almost equivalent to star 214 in the old syllabus. So I would like to share my screen. My name remains Dr. Timothy Ogunleye, and I would like to share my screen with you now so you'll be able to follow me as I move on. Thank you all. So you will see my screen. You will see my screen now. Okay. Yeah. So you can see my screen now. Algorithmic modeling, regression with complete data preprocessing pipeline. Now the step 1, data understanding and structure inspection. I have imported these data sets using this line of code. After the line of code, before you import data sets, you need to write this code, import pandas as PD, because we are going to use PD inside this code. That's why this one is important. So I may ask you in your exam that you should write code to import the data sets, and I may give you the parts, data parts. I'm going to give you these parts, and I will ask you to write code to import data set like this. So after importing, then I may also ask you to write probably to write the data sets to give me the first 10, to show me the first 10 data sets that you have imported. So data set here is named my data. That's the name I give to it. And look at this place. You will see that you have pd.read_csv. All these ones I've taught you in our previous class. I've taught you in the previous class. So then this one, my data.head or bracket 10, that means to show me 10 data sets, 10 of them, the first 10 of them. That's the meaning of this edge. So, and also if I want the last 10, I will ask you to use what? To use a tail. This one will be my data.tail, then bracket 10. So if I ask you to show me the first 7, what will happen in this place? Who can tell me? Please commit yourself and tell me what will happen in this place if I have to show me the first 7 data points. Is anybody hearing my voice?
We're
Please.
going to have the output as 6.
As 7. If I say
The
show
output
me
index, I
7,
mean.
Open bracket 7.
open bracket 7, but the output you have will be 7, not 6. So it will be 7, not 6. When we start from 0 is the first index of Python. So 0, 1, 2, 3. If you count this one now, this one is 10 now. It's not 9. This thing you are seeing here now is not 9. It's 10. Because 0 will be counted as part of those things as from index. That's just index. So now, after that, I've explained it. What I'm explaining here is just what I have the code above. I've explained it for you. If I have to show me the last 10, use tail for it. So this also is explained. It's explained like this. So now, if I want to know the shape, the shape means the number of rows and number of columns. So I may ask you to write Python code to determine the number of rows and number of columns simultaneously. So the code is just what? It's just my data.shape. You don't put anything in the front of shape. Just say my data.shape. And that will give you the number of rows and number of columns. So the data set now contains how many rows? How many rows now? Contains 53,940 rows. How many columns? 11 columns. Look at it here. Columns 1. Carat is number 1. Cut number 2. Color number 3. Clarity number 4. Depth number 5, 6, 7, 8, 9, 10, 11. That is how it is till the end. So you have 11 what? 11 columns. So now I've explained this. All I'm writing here is explanation, and I've explained them. So go through them, you explain them. Now also, I may ask you to write Python code to determine the list of all the columns that exist in another set. So if I ask you to do that, the list of another set, that means you are going to write what? That does what? Does columns. Columns. It must have S in the front. Columns. And you don't put open and close bracket there. Just say columns. How you say columns? That means it will bring out all the names of those columns. All the names of the columns will come out. And that is carats, cut, color, clarity, depth, table, and so on and so forth. Then I explain it to you. Then also the next thing you have to do is what? Is info. If you want to know more about the information about data sets, so the info here is matter.info. It will determine the information about what? Data set. The carat you are saying here is a non non-null count. That means it's non-null. That means it's something that contains non-null elements and is a float in type. Float 64. When we say float, a float is defined as a type of the numeric type of data type that contains decimal. That means it has decimal. Let's go and see carats and see if it has decimal. See now, carat has decimal. That's decimal. That's decimal. So float is something that has decimal. Why the words? I think I taught you that one in your second semester of under level. Floats, numeric, and complex under the numbers. So now also this chords also is for objects. Why the color is what? Is objects and so on and so forth. That's the information about data set. So I may ask you to write Python code to determine the basic information about data sets. So the code is mydata.info, open and close bracket, and you are done. Once you write that, you are done. So all this one will come out in your exam, they are just small mark, 2 mark, 2 mark, 2 mark, 2 mark, 2 mark, till the end. That's just it. That's just it. I hope you are getting me now. So hope you are getting me now. So your exam may be something that is very technical, something that you can see that that will carry like 2 mark, 2 mark, 2 mark, because I will not stress you much in your exam. So something like 2 mark, 2 mark, 2 mark till the end. So now I want to tell you more about describe. That is a descriptive statistics. Descriptive statistics. So if I ask you to write code to determine some statistics, that means you are going to make use of describe. All this one will give you what is called descriptive statistics. And part of them is what? Mean, standard deviation, minimum, 25%, that is Q1, that is first quartile. 50%, that is median or Q2. 75%, that's Q3, or we call it upper quartile, the maximum. So that means under carats, carat is numeric. That's why we have all these now. So all these things you are using here now. So the Python has selected only the numeric figure out, numeric of them out. So while some other variable, consider 1, 2, 3, 4, 5, 6, 7. Only 7 are numeric. That means the rest 4, they are categorical data. You can see from what you have from this data set, you can see that color is not a numeric figure. Clarity is not a numeric figure. Cut is not numeric. But the table is numeric. Price numeric. X, Y, Z, they are numeric. And surface area, and so on and so forth. So they are all numeric, but all those ones who are non-numeric are removed out. Then I've explained it to you here. Also, I can be asked to find the analysis, including all. All means that you should include everything. That means all the variables will be included. That is enough. Include all. That means if it's numeric, if it's categorical, or whichever way it is, all the variables must be included. So be very careful whenever I ask you to write code to determine only the analysis for numeric figure. You only write describe, describe, open and close bracket. But if I say include all, that is, let your statistical computation include all the variables. So you're going to write it in this pattern. So the next thing is step 2. And our step 2 is what? Data type and foundation. Data foundation. So the next thing is to determine data types. data types. Can you see the results? And I explain to you. So now the next thing now is that we want to how do you undo some of this code here. So now this code here, look at this. What I'm saying here, as I tell you that whether each column contain number, text, date, or category. For example, it may show that one column hold numeric value while another hold words or labels. This is important because different type of data are handled differently during analysis and modeling. Knowing the data type help you decide which columns need cleaning, conversion, or special processing before for analysis. So now the first thing you have to do if you want to undo what is called data types there, data conversion and conversion, you will see that what we have here in carats is float 64. So we want to convert these carats. The meaning of this column, this code you are seeing here is to convert. Look at my explanation now. In simple terms, this line of code are used to clean the data by making sure columns contain only numbers. So can you now see this code here is to make sure that columns contain only numbers. For example, if you are typing if you are entering, if the person that entered the data set wanted to enter maybe like a 0.78. So if that person is supposed to type 0.78 and by mistaking that person type O instead of 0, because there is a 0 is different from O. 0 is numeric, while O is categorical. Hope you're getting what I'm saying here. 0 is numeric, that is 0.78, and that person mistakenly type O, that is alphabets, 0.78 instead of 0.78. So this line of code will clean that data set, will clean it and make everything there be numeric. That's what I'm trying to say in this place. So any question? So if there's no question, all the line of code I have for that. This also is to make sure that this also is used for those that are categorical. So in this case, so I've explained there to you. If you look at these other types now, I said Manhattan courts as the type. This is telling you that I want to make sure that all the non-numeric are in a very are converted into category. They will leave objects to category. The difference between objects and category. When we say object is probably the name of a person, maybe like a house, or maybe like the tea, maybe like a cake, maybe like a bicycle. But when we say category means that we want to categorize it and bring it up to the extent of having it in terms of classification. That's the meaning of category. So we want to remove these data sets, cuts, color, clarity. We want to remove them from objects to category. So this line of code is to undo other type category, run the following command. So to take them from objects to category. This line of code to use. And all those ones I've explained in there for you. Now the next thing is to determine the outliers. How do you determine the outliers and treatments? How do you treat them? How do you treat them? Methods of determining outliers. I've told you the meaning of outliers sometimes ago. The outliers are when numbers are too high or too low. You are in class now, 200 level. So if your age is in between 17, 18, 19, 20, that's normal age that's supposed to be in your class. So if you now have somebody whose age is 47 or 43 or 45, that person's age is too higher than others. That's an outlier. Or if you have somebody whose age is around 6 years or 4 years in your class, in university, 4 years old in university, that age is too also an outlier. So outlier is when number is too high or too low as compared to others. So now we can determine outliers through method 1, Z-score method. for detecting outliers. So if I have to write number of to write a line of code to determine outliers, this is what I want to write. This is everything here is what you should write. Don't bother about the result, because your exam will contain writing only code down. You will only write code down, not the results, because you are not practicalizing it. You're only writing the code down in the exam. So all these results, don't bother about them, unless you want to price them yourself. You can go and price them yourself. All the results, don't mind them. So now I've explained the outlier for you. All these things I'm saying I'm doing here is explanation. I'm only explaining the outlier for you till the end. So method 2. The method 2 is a modified Z-score method for detecting outlier. So I may ask you, list 2 methods you know to detect outliers. Number 1 is Z-score. Number 2 is a what? Modified Z-score. So, and this modified Z-score, this is code. This is the code. I collapse the code for you so that I'll be able to see it here. So method 3 is what? Interquartile range, IQR. That's method 3, interquartile range, IQR. So before I move further, is there anybody I want to have any question? Anybody, any question?
No question for now, sir. No question.
Okay. You're getting it because I've already shared the note with you before, so I asked you to go through the note before I can start. So now this method 3, interquartile range, I collapsed this code because I will not ask you in the exam, but you need to know the methods. That another method to detect outlier is interquartile range, but I collapsed the code. Only the code for that first one is what I make active, and that is why I make it mandatory for you here that you must go and cram it to your brain. It's coming the exam. That is certain. Any question? If there's no question, we can proceed. So, but you must go and know the methods to determine outlier in data sets. Now, how do you handle it? How do you handle outliers? Number 1, you can use logarithmic method. Logarithmic transformation, and you take the logarithm of all data sets. So when you apply logarithmic transformation method, so this is a method, that's method 1, and the code is active here. So I'm going to ask you also this code in the exam. That is certain. I think you are getting the logic I'm telling you now. So and I explain the code for you, each line of code. I explain everything for you here. So now, what is method 2? Method 2 is what? Winsorization method, or we call it capping method. That's method 2. I collapse the code also. This is the code here, but I collapse it because I will not ask you the code in the exam. That's why I collapse it. I will only ask you, how do you handle it? So that one is settled. Now also, we go to handling missing values. There is tendency for missing value in data sets. So how do you detect missing values? Number 1, this is the first method. My data underscore clean dot e is null, open bracket, does sum, the open bracket. So this one will give you all the summation of all the missing values in each of the variables. The variable carats has 8 missing values. The variable cuts has what? Has 20 missing values. The variable color has 7 missing values. The variable clarity has 25 missing values. The variable depth has 4 missing values. The variable table has 11 missing values. The variable what? Price has 3 missing values. So that means only the variable z, the variable x has no missing value. Can you see? 0. Why variable z also has 0 missing value? So only 2 of them has no missing value. I think I'm communicating. That's the code to get the missing value. So if you want to convert the missing value into percentage now, that means you have it as carats has about 0.1% missing values. So why the x has what? At 0% missing value. So you can see this is just to convert to percentage. That is all. Now I've explained it. Now, how do you handle it? When you see that there's a missing value in the data set, how do you handle it? You can handle it what we call something. Then if it's a numerical variable, you can use what you call simple inputter. That is inputter method. Inputter method. If it's numeric, inputter method. That is, inputter method means that you can take either the median of that value. This place now, you are taking the median. That we're taking the median of other values, and we calculate the median of other remaining values. We now insert the median into those that are missing. That's what this one is telling you. So if I ask you to use inputter method by applying mean, so this place will change to what? To mean. Are you getting me at all? Am I communicating? I will also ask you this one in the exam, that if all the variables, if the following variables are numeric, write Python code to handle the missing values using mean approach. So the method is inputter method with median here. If I have to use the mean, that means this median will change to what? To mean. That's the meaning. And I've explained this. My explanation is this. So now, if the variable is categorical, you know I told you the meaning of numerical and not categorical. Numerical means that they are numbers. Categorical means that they are what? They are categories. Category, color. You have red, blue, green, white, yellow, and so on. So that's color. So you have chords, different clarity. So all these ones, they're not real numbers. They are what is called category. They are categorical variables. And if you want to replace the missing value, you need to replace them through the what? Through the most frequent. The most frequent here means what? Means mode. That's the mode. Do you remember that mode? Mode is what? Is the most frequent value in our data set. So the most frequent you are saying here means mode. That means mode. But don't write mode here. What the Python we understand is what? Is most underscore frequent. That is all. So I will also ask you these aspects. So go and study them very well. And I've explained. That's my explanation. So now after that, we're now going to what we call encoding. Encoding categorical variable. What is the meaning of encoding? Encoding means that we cannot be using color red, blue, color white, color green. So in the code now, we can try to represent all these color by particular values. We can say let 0 represent green, let 1 represent blue, let 2 represent white, let 3 represent yellow. So all these things now, that are the ways, that's what we call encoding categorical variables. So if you want to perform an analysis, you cannot just say, for example, now size. Look at it now, size. You can't say size. You don't say small, medium, large. Python, all these small, medium, large cannot be represented in numerical value. So we can just say that, okay, let's go and use small, let's go and use medium, let's go and use large. No, we have to represent them in our analysis, because only the figure is what the Python will understand and what will compute for you as a figure. So now we represent small to be 0, and medium to be what? Be 1, and also what? Large to be what? To be 2. That is how we represent it. Look at education now. No for education, that means somebody doesn't go to school at all. And also primary, secondary, you can say is 0 to represent no formal education, 1 to represent those that have primary education, 2 to represent what? Secondary school people, while 3 were what? Tertiary institution. I think you can see it now. And so on. And that's what you call encoding. And the formula and the code for the encoding is what I've written here for you. So please, you need to get it and also let it be in your brain. And also you can write the code to count the number of all these things. Look at the cut now. Cut alone has about so many variables here, so many categories there. I did, premium, very good, fair. So how many I did do you have? You have this. How many premium do you have? You have this. How many very good you have? You have this. I've explained all this one into it. Look at the color. G, E, F, H, D, I, J. These are the numbers of colors we have. Then color G has the highest number. Color E followed. Then color F followed, and so on and so forth. So the same thing applicable here. All these codes, go and study them. They follow the same pattern. They follow the same pattern. So now we go to future scaling. What is my feature? Feature is what you call independent variables. So feature is the same thing as independent variables. That is our x. Why our y is what? Is what you call target variable. So feature is called independent variable. Why our y, which is dependent variable, is what we call target variable. So this feature means independent variables. So when we say feature scaling, that means we want to scale our S variables, we want to scale them. You know, all these variables are not in the same direction. Some are categorical, some are numerical, some are this or that. So we want to scale them. How do we scale them? Then we write the formula for standardization method for scaling for feature scaling. We standardize because standardize everything, make everything to be the same pattern. That's the code for feature for standardization. So now also feature engineering. We can also engineer, we can also create some variables that are not in data set before. We can try to bring it up and try to add it to the features so they can have this feature engineering. And that is the code. And the code is what? Is this page, feature engineering. So go and study the code. And also we can now have what's it called the heat map. Heat map is to know what type of relationship that exists between all the feature variables, all the x. When I say x, I mean independent variables. So what are the relationships that exist between color and what? Between color and what? And then this we have this we open 19 minus open 16. So these are the just study the what we call the code here. So write the code to prepare what? To prepare heat map diagram. That's the code. Then also we are splitting the data into two. We have what we call train data, what we call test data. So the train and test data, we have together like this. So that train data, now that means usually we take 80% for the test and also 20%. So 80% for the train and also 20% for the test. That means the data set like this, we take 80% to test. Sorry, to train. We train 80%, while we use only 20% to do what? To test. So this is the code that we make use of in this direction. So you can ask me any question here and I will answer you if you want to ask any question. So you want to check the ones you have already trained, check. Then we now go to simple linear regression between carats and depths. Carat and depth. So we consider carat as x and y. The y here is what? Is depth. So y the s here is what? Is carats. So we now have this results with that code. Then we interpret. This result also, I can give this result in the exam and I will ask you to interpret it. So this is look at it now. Look at it now. You have look at it. Look at AIC, BIC, and also look at the F1 score. 0.01. That is too small, too small. And where is the F? This constants. And this what? This is the main result. Look at it now, constants, and what it now, and the depth. So remember the carats. Carat is what they call carat is the y. Carat is y and x. So the x here we are seeing here is what? Is depth. So depth is the x. And the value for the p-value is what? Look at the p-value. 0.000. That means it is very what? Very significant. If the p-value is less than 0.05, it means that variable is statistically significant. That's how to interpret the p-value. And this p-value here. So that means this depth is statistically significant as compared to that carat. I've explained everything here you are seeing here. I've explained it here. So to obtain the evaluation metrics, these are the code for the evaluation metrics, and these are the results. And also I've interpreted it for you. So I've all displayed the result in graphical, the graphical results of carat and what and depth. So I've given you this. What are the uses of scatter diagrams? Uses. I don't need all these stories. What I need in the exam is what? It is used to detect what? To detect the relationship between variables. Number 2, it is used to assess linearity. Number 3, it is used for identifying outliers. Number 4, it is used for evaluating strength of association. Number 5, it is used to understand direction of effects. Number 6, it is used to support model diagnosis. Number 7, it is used to compare actual and predicted values. Simple. All these stories under here, I don't need them in the exam because there will be no time for writing the exam, but you can read it for your own consumption, for your own personal research. So, and now we have libraries for it. We have the code to determine all those plots, and the result of that code came out. And the results here, see the results here. Residual versus predicted. That is how I did it. And I also have the uses of residual versus predicted plots. We call it residual fitted plots. The uses is what? To check linearity of the main structure, to detect heterogeneity, to detect heterogeneity that is not constant variance. And three, to identify model misspecification. Number 4, to detect outliers and influential observations, and so on and so forth. Go and read them. And that is something I did till the end of the course. And also, I also did the graphical result of actual and predicted values. And I also have it in in written form. That is their uses, conceptual description, ID interpretation, and so on and so forth. So go and read them. Also, they're all ratings. So that is also the end of the course. They also have QQ plots of residuals. So what are the functions? Usefulness, QQ plot. These are the usefulness. Just give me the points. That's the point I need, and you are good. You are good to go. That's all. So the same thing is done here. So that's just it. So go and study them till the end of the course. That is all. So I also prepare by myself, and that is my website. And when you see my website here, you click on my website, you see that it will take you to. You click on my website here, it will take you to another grant. That is it. So this is my personal website, so you can click on it and check more about my profile, and also from there you can move on. So if you have any question that you think you want to ask, please, you are free to ask me questions, and I will try to attend to you. The notes are with you before now, and I'm sure that many of you have the notes. These are my profile. If you go through my profile, you will see so many things that you want to know more about myself. You see, go through my profile, so you see more about my profile, and you will have more information about your tutor. So that is just about my profile. Then, any question, please? Any question, please?
Yes, sir. Yes, sir. Please, one question, sir.
There's no question. So this note and the previous ones are the one I'm going to set for your exam. So just go through it, know some code. At least I don't want anybody to fail by the grace of God. I don't think anybody should be able to fail this course by the grace of God. So, and I don't